All right, hello, welcome back. So, yeah, so we are currently doing the runic IR. So basically, yeah, so I'm making a bash-like scripting language called runic, which is gonna have zig-like syntax like this here. So just give you an idea if you're new here. And then now I'm working on an IR version of the language, and yeah, I'm just trying to implement everything. So right now I'm trying to solve this bug here with the grep not really working. So what we've got the IR up to now is basically having blocks as part of pipelines, which does work. However, there is some issue with grep specifically, and I'm not really sure why. So I'm trying to improve the debugging messages and the debugging kind of framework for this. So what I'm doing is I am currently making this trace functionality. So we have these trace messages that can be used to basically log, and also we have for each trace there's like a severity, and then you have tags, which is also like used to kind of filter, so that we can output a bunch of information. And if you want to filter on that, you could do that. And then also potentially if it's connected to any point in the source, we can also show that as well. Could potentially also maybe produce, yeah, I'm thinking maybe later we'll maybe have a more general like execution context stamp, basically like copying some kind of execution context in which this was in this where this trace was actually executed or logged from. Because right now we only have like span, and yeah, and that could point to a source, that could point to a line and a column in the source code. However, it would be cool if we could also have like an instruction address maybe, or something else. We'll see. Hello, Code Guy. What's up? What's up? Welcome back. How's it going? But yeah, so right now I'm trying to get this up and running. I've added the tracer to these trace things to the evaluator, I think. Yeah. And I'm currently trying to add commands to the debugger so that we can set the trace options. So here you can set trace options on and off, so that they kind of are they going to be logged or not, like out to stand it out. It's raining. Okay. Well, here it's like, I don't know how, like negative 15 degrees or something, and snow, which is nice because it has been a while since we had a real kind of snowy winter here. How many degrees do you have? Yeah, there's snow. There's snow in Sweden. I'm not sure how much there is in southern Sweden because it's such a long country. So it's like in the south there's like, I don't know if there's even snow right now, but then in the north there's like a lot of snow in the winter. And since I live like in the middle somewhere, like not really the middle, but south middle, maybe you could say, that we get like less snow. But 26. What the hell? Did where was that? Was it you who lived in like the Middle East or something? There was someone who said that anyway. Oh, India. Okay, yeah. Sorry. Yeah. So India, that's near the equator, right? Or is it further south? Man, I'm so bad at the geography. World map. Where is the equator actually? What? World map. Yeah, I was looking at like Google Earth and that didn't help me. North of equator, okay. But it's just about. Why don't they show the equator on these maps? Oh, there's the equator. Oh, okay, so all of India is north. Okay. But it's pretty near the equator. Yeah. And Sweden is like inside, well, north, the top, I don't know, 5th or 4th or no, yeah, something is like north of the Arctic Circle, which is where the sun, in the summer, the sun never sets at some points, and in the winter, the sun never rises at some points. So it gets really cold in the winter, and I guess in the summer it doesn't get that hot, even though the sun is out all the time, because it's like, because of the kind of angle of the sunlight that hits the land or something like that. There's probably other reasons as well. It does not snow in the south part of India. Okay, does it snow in the north part? Because also the thing is, like, if you're also like on top of mountains, it's colder as well. So of course you have snow, but we don't really have those high mountains here in where I live, at least. But north of the northern India has like huge mountains, right? Like the Himalayan, or what is that called? Maybe there's multiple. Kashmir. Okay, cool. Let's see. The tracing can turn on and off. Filter. See if we can get this working here. So filter. You never saw snowing in IRL. Okay. I mean, I guess some parts of the world it doesn't really have seasons either. It's like if you live on the equator, basically, there's almost no difference in the like different seasons. But up here it's like major, it's like night and day. No, that's too bad. Yeah, I mean, it costs a lot to travel. I mean, I don't do it a lot, but either. So, but hello, Manasikara. What's up? Okay, so we've got the filter command, filter type, any that we have there. Okay, so I think, oh yeah, there was this weird syntax error that I couldn't find where it comes from. Like if I delete this, there's some, like somewhere there is some kind of syntax error somewhere, but I can't find it. Like if we remove this, yeah, it's still some. I'm trying to scan with my eyes where it could be. $3,000 to travel properly. Holy crap. Well, that is way more than it costs. I mean, I guess it depends on where you want to go. I know that because I've been to Spain a lot. Well, a lot I said, but a lot for me, I guess, relatively later in my life. Like, not every year, but almost. And one ticket would cost like $300 for to fly to Spain. But that's also, I mean, it depends, of course. It depends on when you go. It depends on where you want, like how long is the flight. If it's, you know, if many people are flying at the same time, like if it's like, you know, vacation time, or then it's like more expensive. But if you fly just on a random, you know, day, so you don't fly at those times. Or you don't go at those times. You would go when no one else is going. So then it's cheaper. And also you have to, if you order like before, you know, if you want to go, you order like, you know, half a year in advance. It's also cheaper. But then I've seen like flights to Thailand, for example, that goes for like $2,000 for one ticket. I don't remember if it was like if it was a return or not on that, but yeah. We can afford to live here, but to travel like all the time, like every year, no. I mean, of course, it depends on how much you want to spend and stuff, but yeah. I mean, it's nice, but I also like the comfort of my home as well. So yeah, I'm with you. Now that we have computers and TVs, we don't need to travel. But where is this error? If I remove this entire thing, is there still an error? Yes. Where is this? I mean, it might be from before or after. Already here is like the you can see the syntaxing is off. I'm not sure if that indicates if it's near here. It could be somewhere else. I'm looking at the new. Now I'm using the git signs to see. Not the multi-line string. Don't think so. This thing. No. I mean, it could be multiple as well, but yeah, this one, command usage. I'm probably not gonna face cam. I'm not gonna do VTuber either. I don't know. Is that like, is it like a thing where if you have face cam or VTuber, do you get more views? Do you get more attention if you have that? Or rather, are there more people interested in seeing a face or a VTuber than not? I should say. Probably, maybe, I don't know. Maybe in the future, we'll see. Maybe when I can live off of this, I can start that, maybe. We'll see. Man, this thing is... What the hell, man? See, over here as well. There might be some weird syntax issues. I did a bunch of changes, so there might be some strange things somewhere here, but I'm not seeing it. I'm just gonna try and undo here until this error disappears. Because I can't find the issue. Have a nice day, Polaris. Welcome back. Build some kind of connection with viewer. If you're not shy, you can do. Alright, I see. I'm probably not gonna do like a VTuber. Don't ask me why, but it just doesn't feel right for me. I might do face cam, but maybe not now. No, there's still some issue. I don't understand. Okay, let's do this. Let's go back. There. Okay, let's do LSP restart. Because there might be some weird... No, it's still there. What the hell? Because I know that it complains here, but the problem is not here. The problem is somewhere else. There's like a syntax issue somewhere. So the parser is like reporting the error here, but it's basically just because there might have been like, unless I'm just blind, but it's like there's some syntax error somewhere else which causes this parse error here. But I can't find the cause of this parse error. Even if I revert back to like the original file, it seems to still be there. Like, let's say we remove like all. We go here, remove everything. It still complains. No, now it doesn't. Okay. Okay, it complains over here. So, okay. So maybe we need to save first. Okay, now it actually disappeared. Okay, so the error is somewhere in here. The error is somewhere in here. So now we just need to scan this place to find it. Okay. We have an if, we have this. Yeah, this should be fine, like, or else return something else. Equals, yes. I just have to go through very meticulously, or whatever it's called, to see if I can see the syntax error somewhere. I have to scan with my eyes. Print. Breakpoint add. But this is like I haven't changed this part. Wait, did it go to the wrong place? No, if I remove you, the error disappears. We get another error, but we don't get a parse error. Right, okay, I was looking at the wrong place. It's in here. Trace. Yeah, same thing here basically, but a little bit different. If not equal null, trace, filter all. Tag, append. I mean, it might be here. So if I do this, okay, no, wait. Okay, so it is in this if here. I don't know, can you see it? I can't see it. What if we remove that? Also, the error actually was there. I was like, but I don't see the error though. So that was what I was. That was why I thought it was somewhere else, because this doesn't look like an error to me. What if we say undefined here? There's still like an error here, so undefined. Okay. Oh my god, okay. I know what the issue is now. Man, this is so stupid. Okay, this should really be a different error here, I think. It's like, because we're the reason is that and or, first of all, they are not named and or. These should be tags and tags or. Okay, now it should work, right? But why does it work? Why is that such a huge error? It's because and or are keywords. So now the parser is all messed up. It's like saying struct or if I say anything else. You see the parsing now You see the colors up here. If I say struct, it messed up. If I say union, it's messed up. And messed up, because and is a keyword. But okay, I was really fooled there by, well, I didn't think about the keyword there. It's like, it's just something when you think about field names or like names of variables. It's like, if they happen to shadow a keyword, in some languages it's fine, in other languages it's like a no-no. Well, actually, maybe variable names is a bad example, because a variable name would shadow the actual keyword if you're trying to kind of use it. But if, let's say it's a field name, for example, if it's a language where you have to kind of refer to the field with a member access, like self dot field or this dot field or whatever, then it's like no problem really. Like in JavaScript, for example, you can have a field called class, even though class is a keyword. So usually I don't really think about keywords when doing fields. Also, you don't really see the syntax change of this part, but if you would say and here, well, okay, it doesn't really show here, but true and false, like this. And is a keyword, but I guess it only changes color when it's like in an actual binary expression there. But okay, anyway, enough of me trying to explain away why I didn't find this. Okay, I just thought that was kind of interesting, like how much time I spent on trying to figure out what the issue was when it was really, really simple in the end. Okay, let's continue here. So you, well, let's just add an error type here, and then you need two. Oh yeah, we need self dot. That's right. Okay, there we go. Now let's try this out. So if we go to the thing, start a debugger, and actually what I'm gonna do is I'm gonna go to stream. I'm gonna disable logging here, because now we're using a different system for this. So this would become deprecated, thankfully, soon. And then we have process, and let's disable here. Okay, that should be all, I think. Go back here. Disconnected sources. Where is this coming from? See, even now we get like immediate information here. Yeah, so now we have these trace things. So we have a tracer and we trace, so that will create an entry. It's also stored in our list now, so you can kind of query it later also. So basically we have a type of kind of trace type here, and then we have the tags. So then you can potentially filter on tags. So this would be like stream, you know, the function name here, disconnect sources. I had added some random like tags here, disconnect source. So if you want to find everything related to streams, you would filter on stream tag. And then we have the span, which is null here for this one. And then we have the message. And then we have, you know, this is like a print format here, where you have the format function, the format string, and then the arguments here. So this would show which sources we disconnected, I guess, if we disconnected any sources. I guess if we didn't have any sources, we wouldn't maybe we don't really need to say. No, disconnected sources. That. Wait. Stream disconnected sources. It should be this one. But why is this empty? It's like an empty list. Oh, I see. Connect destination. Wait. Okay, I'm gonna do this. If sources to remove items length is more than 0, then we do this. Okay. Now we don't see it, but I did notice an issue, and that is it doesn't print a new line. So let's go to our trace thing. And no, tracer. Here's the tracer. So whenever we call this function, this is like the meeting point of creating a trace. Then we check if, so we add it to our list of our log list here, and then we also check if we need to echo this to stand it out. If we do, then we print the thing out. However, I want to add a new line here as well. So if we now step, we should see a bunch of logs now, or not. Okay. I thought it would like connect stuff, but maybe not. So a bunch of forks. Okay, here we go. Bytes forward, error, bytes forward. Why does it say error? Well, this shouldn't be an error. I think it's because I copied this from before and I forgot to change. There we go. Yeah, bytes forward at 0. Thank you for that. I guess it's good to know. It would be cool if, like, yeah, I'm gonna do this as well. Depending on the type, we're gonna have a different color. So when we do this, it could be built into the format of the function. We could also make a wrapper that like colorizes the trace as well. So we could have like colorize, which so it just needs self, and then we get a colorized trace. And then we have a different format function which would colorize it depending on the thing. So this would return trace itself. Right. So we would print, and so basically we have two strings, which is the start color, end color, and then we have format of self. So this would be self. Let's have like severity color trace severity. Now this is just an enum, so we should be able to kind of use it as an index, perhaps, or we could have a function, or yeah, we could have a function, and then end color there. So let's import our color library. Severity color takes a trace, or maybe a severity. Server? What do you mean server? Oh, yeah, that takes the severity. Actually, that could be part of severity, actually. Color. Oh my god. So, error is of course red. Actually, you know what? Let's do like rainbow color, actually, so that it's even more. Warning is yellow, because then you can use it as a background color as well if you want. Information, I guess we could do like, what do we have actually? Maybe cyan. Wait, do we have cyan? Maybe not. Well, we should be able to have cyan, but let's do blue. Information, hint. I don't know, violet. All right. Okay. Now, where were we? Right, so here we're gonna say rainbow begin color, severity color, and then rainbow end color. There we go. So now it's colorized due to what severity it is. And then down here, when we print, we should say colorize. There we go. Now let's see how this looks. Okay, what the hell? Why is this an issue now? And why do I not get any information? What the hell? I mean, yeah, it might be that the standard log, like there's some issue, there's like a issue there. There's some error happening. However, if it happens here, we just ignore it basically, and we abort the tracing. Okay, let's do trace off and then try to step. Okay, now it works. So there's something weird when we try to print this out as a color like this. This is weird. Because, yeah, we get a struct out. This struct is copyable. This is the underlying trace is a pointer, so that should be fine. And we do set it up, like we do set this to self. Like, what if we just do this? That should technically be the same thing as we had before, except without the color. No, it still breaks. Was it maybe there was something else? No? What the hell? Go ahead and sleep if you feel like it. Maybe you need it. So just the act of creating this wrapping trace have a different format function, and we print the formatting of this, which should be this here. And of course it's a pointer. It has, I mean, the pointer thing has worked before. Oh, I see. Okay, I think the issue... Yeah, okay, I see what's going on. The issue is the interface. But no, that doesn't make sense. No. That does not make sense. This should be a pointer to where it's supposed to be, and it's supposed to be part of a basic trace. So that doesn't make sense. I was like, the interface is like, yeah, now we're wrapping this on here. But really, if this was a problem, it would have been like this. Not like this. Because of how interfaces work. Wait, format self? Oh my god, format self.trace. There we go. Okay. Never mind, there's nothing to see here. Let's move on. Oh my god, okay. How is it 4 nanoseconds? This has to be like seconds and not nanoseconds. That's weird. Okay, but anyway, now we get this information with color. Great. So that was execute. No, wait. No, there's all these refs. And we disconnect sources for some reason. No source. We disconnect no sources, right? Yeah. Alright, getting ready to call tail. If we look at the pipes now, it's kind of hard to see, but this is standard out, goes to well, the source is grep, right? So that feels correct. Standard error is the same thing. And then we have this pipe, which goes to grep. We have this pipe, which goes to pipe, which is this pipe over here. Because it wouldn't go to itself. Actually, I have no safeguard for that, but that shouldn't happen. We execute tail. And then we can look at here. So now this pipe has the source of tail and destination of this pipe, which kind of bypasses the source here and goes directly to grep. Which is one of the weird things about this. I really need to figure out how to do this better. The pipes are, yeah, we need to make them work better. But there's that. So here we can see, yeah, there's no bytes being forwarded from tail. Yet, I guess. Nothing. There we go. Now we get 121 bytes from tail, I would assume. And everything is still connected. So it was forwarded. So if we look here, it was forwarded from tail to this destination, which should be directly writing to grep. And then when we do the streaming of standard out, it should read from grep as well. But that is not happening. Like, well, it is happening, but it's like there's no bytes happening. Also, 128 bytes seems too low. Or maybe it isn't, actually. Maybe it's exactly how many bytes it is. But now we're kind of stuck here, because nothing is really happening. Tail will not exit. And grep, for some reason, doesn't really forward anything. But if we change this to cat, for example, we are going to see there's grep, I think. Was that grep? Okay, both cat and grep is... No, I mean cat. Yeah, that's cat. Okay, and then we're waiting for tail to start. Where is tail? Okay, next round. So there we go. Now tail has spawned. And tail doesn't have anything to give us yet. There we go. Now we get from tail. And we should see now. No, maybe next round. No. Next round again. There we go. Now we get from tail. So you can see that this setup does work, but for cat, but for some reason with grep it doesn't work. Also, we know that this is like standard out and not standard error or something like that, because that's what we're reading from. So I'm confused. And then it's just gonna complete here. Well, actually it's not completing because of tail is never gonna close. So so for some reason grep does not work here. But if we echo something, hello, does this work? Oh, it's printing out these things now. Wait, this is weird. We get like a memory. Oh, I think it's like it's showing standard error first and then standard out. Okay. But do we get the hello though? No, there's no hellos in here. So there's something going on with grep. I'm also gonna go to run script, run IR, and actually let's go to tracer. Let's do false there, and then when we do like debug, we turn it on. Okay, so now we should go. So we go back here and we get like a leak. Trace. Huh. Why do we get a leak? Yeah, this is the arena, so one more 400 subs. Yeah. On YouTube. There's like a magic limit at 500. Wanted to get into Zig. What kind of projects can you build with it? Anything. Anything you want. It's a general programming language. It doesn't really cut you off of anything. Like, you can do whatever you want, but basically, but it is low level, and I mean that's part of the reason why you can do anything as well. You can like highly optimize and all that, but yeah, I mean you can do anything. It's just if you can build it yourself, you can do anything. But if you're looking for like libraries that does, you know, certain things, I'm not sure. What kind of things are you interested in building? Like games, web servers? Can you explain what you're trying to do here? Yeah, so I'm building a new language that is supposed to be like Bash, except with more like a programming, more like a programming language syntax when it comes to things like if and for statements and expressions and all that. So this here is like, this is not showcasing any of that right now, but they were. I'm kind of trying to fix this this expression here. Actually, it doesn't really have to do anything with a block, but right now I'm trying to fix why. I'm trying to understand why grep doesn't work here. It works with cat. I can show you. Let's see. Let's do. I usually go into here. So here's the language right now. How it works. So you can call these bash like expressions, but redirections are not implemented yet. But everything in this file is implemented for kind of the basic version of the language. Right now I'm also like rebuilding the language, but anyway, so we have, you know, if statements is looking like this instead of, you know, if semicolon then and so on. So this is the if statements. So it's basically it's kind of looking like, you know, C, except it's zig syntax, as you can see here in the for loop is where you see like a zig based syntax here. So you have a range, and then you have a capture where you capture the source here. And then we can also look at, this is how it looks in Bash. So this is kind of a comparison of the two languages, you can say. When are you completing this one? Which one? I use mainly Elixir and JavaScript TypeScript professionally, so I'd like not to work with web servers. Just wanted to expand and see what Zig has to offer. Games sounds interesting. Yeah, I mean, you can make games. There's like, you know, you can use Raylib, for example. Raylib is a C library. So also that's the thing, like any kind of C library is also, you can use in Zig as well. You can basically import C libraries and you would get like auto completion, type conversions. Basically, yeah, it's really nice interfacing with C. So Raylib, for example, is a C library, so you can import that, which is a really like easy to use starter, I guess, like game library that you can use to build like simple games, I guess. And then you can also, I think there's like a physics engine called like Bullet that you can use as well, but I've never tried that, so there might be some C libraries that are harder to use. I don't know, but Raylib is really easy. They also have their own like zig build file, so it's a C library, but it has a zig build file. So that tells you something about zig. So you're trying to focus on optimization like C, C++ and make it object oriented, or just purely bash? No, it's gonna be still like a scripting language. It's gonna be very simple. The only the like upgrades that I'm doing basically is the syntax, expressions for arithmetic. So if you go down here and look at the expressions, like in bash, you have to kind of surround this with double parentheses, but here you don't have to do that. It's just an expression or a normal statement. What else? Yeah, so that's one thing. And then what else did I think about? It's not going to be object oriented. We might implement structs, because that's very zig-like, and it would be cool to have that. Maybe we'll see. But it's still going to be this simple basic programming language. It's just that you don't have to look up every time how to do if statements or how to do for loops, because me personally, I have to look it up every time because I don't even want to keep all this in memory. So I would rather have like a C-like syntax, sort of, except it's zig, but it's very similar. That is consistent, and you don't have like unique keywords for all the different like these statements here, to like for and done, if, fee, what else is it, like case, esac. It's just gonna be the curly braces and more. So it's gonna feel more like a programming language that might like C maybe, but then you have like these kind of like embedded things, like these. You could almost think of it like a C-like language with embedded bash pipelines in it. Also, for game libraries, you should check out. You can join the Zig Discord. There's like an official Zig Discord. I think it's official anyway. It's there's like channel for game dev, so you can check that out. And there's also like a project list. There, if you Google Zig game library, you see also there's a library called Mach, M-A-C-H, but I've never tried it, but it seems really interesting. Also, if you want to look into ECS, there's a library called Zig ECS, which has a very nice interface as well. So yeah, there's a couple of things there. All right, see you later, cool guy. I'm just gonna refill my coffee, BRB. Consider making a simple stylistic RPG game. Okay, nice. Yeah, I'm also making a game kind of put on hold for now, but in favor of this language here. But I'm gonna start up the development of that soon here. Yeah. I'm like gathering a little bit of inspiration and trying to figure out what to do next there. But yeah. But for now, I'm focusing here. Okay, I want to see why we get this leak here, because it should be part of the arena, really. And so this is initialized, and then and then we defer deinitialize, which should deinitialize the arena. So I'm not sure what's going on there. And we're only ever passing a pointer to this, so oh, is it this one? Okay, I thought arenas were that you could do this, and you can basically copy the arena. Oh wait, I'm creating a new arena. Oh. Okay. Never mind. There we go. Okay, so it does work. What the hell? Okay, this is kind of weird. What if we say... Also, if you do like color... Is it auto? Okay, maybe it's because we don't get color in here. But if we do this and then we run like runic blocks, no? Okay. Well, what if we do this? We do subshell tail. Okay. Into grep. Man, what the hell, man? Is it something to do with like how we can kind of forward things into grep? Because it's like, I think we are actually writing to standard in of grep, but for some reason it doesn't actually show anything. Like echo hello. That works. Okay. Echo something. Nothing, so that works. Tail. Does not work. Is there something like we need to kind of... I don't know, man. I don't know. It feels like some kind of internal pipe thing. What if we don't do F? Of course, it's gonna work. And it's not like this is standard error or something. No. Oh yeah, we don't have we don't have redirections here. No, that doesn't make sense. Yeah, I'm gonna add more. This is interesting, like, because it does work with it's interesting because it does work with this here, like echo. Oops. This works. What if we have tail F here? Okay, that does not work. So, is it because we're not closing standard in or something? That doesn't make sense though, because it should write to it. All right, I need to BRB 1 second. All right. Okay. We need some more information here, I think. Now, I've enabled like tracing in the streams. I want to also do the same thing for process. Also, now that we have this, we don't actually need log. Oh, we still have these things. Okay, I'll deal with this later. I just want to add basic tracing things to the process as well. So process closable here. So this thing should have the tracer. Right, so this will be like tracer trace information tags. It's like process spawn. Actually, let's do more generic function name. What else? Span, that's right. Okay. Okay. Same thing here. Now, do we add? Yeah, I think we add a tracer here. Process. So we're gonna take this, put it here, and there we go. Standard in, standard out, standard error. Alright. Hello Metallics, welcome back. What's happening? You know what? Let's do this. Let's do a macro. Close. Oh yeah, parent, tracer, trace. Information, tags, process, source, function name, and no. All right, I think that's it. There we go. a little bit more busy there now, but I think that's, what is that, all the logs actually? Now we have more things here. Wait. Pipe writer, ah. So this is actually, well, okay, process, well, this is pipe writer. We could do like type name, actually, yeah, type name this. Perhaps, yeah. There we go. Tracer, 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 tracer. And of course, this also needs the same thing. No, it doesn't. Well, actually, here this needs the tracer actually. Parent tracer. Yeah. This would have been a good fit for like an AI task. Oh, shit. Okay, we need to move the tracer here. Fine. dispatch. What's your take on AI, using it for coding? I think it's fine, but AI is not good enough right now, so you have to kind of inspect everything AI is doing. And you kind of have to learn how to use it to your best, like how to use it more like efficiently, because if you just use it willy-nilly, it's not gonna be more productive. Like, you could easily end up in situations where you have to kind of rebuild the whole project, or just don't understand how things work, and you know, there could be bugs creeping up that AI is causing and stuff. So it's like you can use it, and for certain tasks it's actually pretty nice, because you could, like for boilerplate tasks, for example, like this that I'm doing right here is kind of boilerplate, where we just have to add a logger that logs a bunch of stuff. So that is one way that AI is good for, is like if you have the same pattern you need to apply it to many places. So instead of doing it manually, you could use AI for that. Another thing is AI could help you write tests. I haven't done that too much, but from what I see, it's like it's nice because they don't really have to do it yourself. It's a lot of manual, like adding tests and stuff, and if AI can do it, then that's really nice. And tests are more, they are like less, you know, they're not going to affect the main code. So if you add tests, it's just and if the test happens to be, you know, an error, like a wrong test, then you can just fix it. But it's nice when AI can do it for you, because that's such a tedious task sometimes. So basically for like tedious tasks, AI is really nice. Let's say also you wanna fix a bug, but you can first ask AI to, hey, could you find the reason for this bug? That is also a really nice use for AI, because the AI could investigate while you work on something else. So that is also a really nice use of AI, I think. But if it's like for main parts of the program, or you know, things that actually require, if you want to have a good architecture, and if you want to have, you know, a strong code base, then don't use AI for all the tasks. Like, you should implement things yourself, and then use AI for tedious tasks, basically. That is how you would. I think that's how, right now, how you would. It might change in the future, but that's right now how you would kind of use AI to kind of increase your productivity. I think, in my opinion. I mean, there might be people who are better at using AI than me that can, you know, solve problems a lot better. But I've spent a little bit of time learning, you know, to use AI and stuff. But I know there's people who try to really trying to figure it out, and maybe they have more insight. But yeah, I know that I could probably spend some time learning more AI stuff, like the MCP stuff, and to kind of increase my productivity. But also then I have to kind of pause everything else and go and learn that. I would rather kind of wait for someone who has like a good general solution to things. Like, we're right now in my workplace, my normal workplace, we are also looking into AI a lot right now, because it's like it feels like, I think last year it started, like this whole kind of AI, all these new tools came out. So people are still like trying to figure out how to best work with it. And it's improving all the time as well, so we'll see what the future holds. So things are changing like rapidly right now. But I wouldn't, you know, you still need programmers right now to make sure everything works. Expected types, especially if you're working with, you know, a sensitive kind of project that needs security to be taken seriously. I wouldn't use AI for that. Well, you can use AI, but then you have to kind of inspect everything that AI is doing. But if it's just a small project that is kind of like a throwaway, or you're making a prototype, that's also very good for AI to make a prototype. But then, you know, when you're done with the prototype, you probably, if you want to make it into a real project, you probably need to like rewrite the whole thing. Possibly, like maybe you won't need to do that, but maybe you do. Right, so now you are a pointer. There we go. Okay. But also another thing with AI is, you know, you can use it for coding, but you can also just ask it questions as well. You can ask it to inform about a code base if you're new to kind of like a technology or like a library or something. Then you can actually ask very specific questions to the AI to actually quickly learn about a library. If you really want to kind of quickly get up to speed, then AI is good for that as well. Now you have to take the information with a grain of salt, of course, because it's AI, so it could just make things up. But it's really nice for asking very specific questions. And then it also, like, if you're using something like Codex, for example, it can scan or Cursor or whatever. It can scan your actual like project directory, so it could look for, you know, things in the project, so you would be able to do that. Where am I? Interpreter. Oh yeah, you don't have tracer. Wait, don't you have tracer? No, it's the scope. Oh, I see. Well, let's just add the tracer here then, because we should be able to do that. There we go. Same thing here. I mean, I guess we could add tracer here, so we don't have to. Because it's like when you ask AI to implement a feature or add a new thing somewhere, like sometimes it does things pretty good. Like it actually implements it pretty good. Like if it's a small task, but if it's like a larger task and you kind of have to think about, okay, do we need like a backing mechanism for this thing? Sometimes it can do things well, but oftentimes it implements things in a weird way, because it doesn't have like the future context of what you have. So if you're just saying AI, hey, implement this next thing, and it only sees like forward one step, but you have maybe 10 steps ahead that you're thinking like, okay, well, if I implement this feature, we could implement this and the other feature with the same kind of backing mechanism, and then it would be easier to do the next thing. But then we need to the first thing to kind of be adapted a little bit, so it can do both things. But then it's like AI doesn't know that, so AI will just implement specifically for the first thing, and then you ask it to do the second thing. Now it might generalize and do this backing mechanism for both things, but it might not. It might create two separate backing mechanisms for two different features, which are kind of almost exactly the same. And so that's kind of where an issue arises. Like then all of a sudden your code base gets kind of fragmented almost. So if you just ask AI to do, hey, add this now, add this now, add this now, at the end you're going to end up with a fragmented code base that is basically impossible to maintain and add more things, because it's like, well, now I want this feature and this feature to work together, but it's like impossible because of how AI built the project. But there might be solutions for that as well. Of course, you can tell AI to, hey, keep this in mind. Maybe you have like more context, like of future features, while actually implementing something, or you yourself do the architectural planning and ask AI not to add the feature itself, but add the backing mechanisms that you believe would be nice, so it doesn't get fragmented or something like that. I haven't tried that, but that seems like a possible solution maybe to that issue. A human written design spec tends to help when generating code, but I found it really shines when it comes to reading or writing documentation. Right. Yes, AI is very good at scanning documentation and giving you answers to specific questions. That is one really nice. And writing documentation is also pretty good if you like emojis. But yeah, it's like if you don't like writing documentation, AI can do it for you. It's like, I don't know, I see it like if there's a task you don't like, ask AI to do it, but then you also have to make sure that it does it in a good way. If you care about the quality, that is. Where are we? So we don't have any errors left. Okay. Yeah, the emojis is kind of strange. Like, I don't understand why it's so obsessed with emojis. It's interesting. Maybe it reads a bunch of chat message, like I don't know. Like, where does it get the emojis? Like, how many documentations have like a bunch of emojis in it? They seem to have a strange obsession with EM dashes as well. M dashes. I'm not sure what is that. Oh, it's like a longer hyphen. Okay. Yeah. I mean, I don't really have a problem with that, I guess. Wait. Well, that's like an extremely long dash. There's an M dash, N dash, and hyphens. Okay. I wonder if someone told AI to, hey, when you produce documentation, make sure to include a bunch of emojis. Okay, so let's see. I'm gonna do like a grep example here. Okay, so if we, for example, if we run bash on this, no, yeah, I think it's because Vim kind of waits for, I think, yeah. So, yeah, that works, but then we run Runic, of course it doesn't work. But now we have process logs as well. And I guess the pipe. So now we can try the filter thing. Process. Now this is, I think this is poll. Yeah, process poll. So if we say trace, oh shit. Yeah, we can't do like negated filtering, but okay, whatever. ChatGPT gave me output with shorts with spaces today. What? I didn't even know that existed. I have better results with Gemini, but they're all meh. Alright, let's see what's happening here. So we're preparing to call or is it tail first? Yeah, tail first, right? Yeah, that's tail. And we already have data out. And that one stream standard in. Okay, and standard out, standard error. And that pipe, this is the pipe. So the pipe doesn't actually forward anything. Yeah, because it doesn't have a destination yet. Okay. So I think tail is basically done now. It doesn't close because of course it's tail F. But now we now grep has executed. It is connected as a destination here. And the next time we stream, so that now, but that's the standard streams. This stream now forwards bytes to grep. Okay, so now grep should have received data. Okay. And this talks about, like, this is talking about the standard in of grep here, which is receiving data. And now standard out here is trying to read from grep, but it's because, yeah, if we look at the pipe here, standard out is connected to greps. So grep standard out. So but here it's we don't, like, the events of poll is 0, so that means it's not closed, but there's no data to read. And you're basically done now, so you're not gonna. And same thing here again. There's no data from grep, but it's not closed. And I think this is what's gonna happen. Like, we're gonna basically never get anything out of grep, and I don't understand why. It should have been written to grep. It should have been flashed. Let's do this as well. I'm gonna do like IR sleep. So echo hello, echo sleeping now, echo hello again, and then we pipe that into cat. So this is kind of the same setup, except, you know, we have a block here with a bunch of stuff. So we should see hello. So if the streaming works, we should see hello and then sleeping now, and then it's gonna sleep too, and then hello again. Oh, I see. I need to do this. See? It does work. So I mean, it is streaming, you know. But for some reason, grep doesn't output anything. I don't understand why, because in bash it works. You know, in bash it works. And grep outputs whatever comes in there. Now grep is an alias. Maybe there's a difference between, like, is grep, like, it's aliased here, but what if is grep actually, how do you unalias? Okay, it's just unalias. Okay, so it is that grep, right? And now, of course, if we do this, still works. Okay. Because yeah, I was thinking like, yeah, it should be flashed. So whatever we are like outputting from here should be flashed into grep. Because if we run this, it works. We get hello sleeping now, and then it sleeps too, and then hello again. And if we bash it, of course we get the same thing. But if we change this to grep hello, we get nothing except in the end. I am so confused by this. Grep. I'm trying to find the source code for grep. Oh, it is? Okay, so it is git grep. I was like, why is this part of git? Okay. So let's try to figure out what's happening here. Where's main? Is this all everything in one file? Probably. I mean, we do have all these things, but main. What? Wait, what did it say? Okay. Grep. Built in. Okay, they might be doing some weird things, like having it in a certain like context or something. I'm trying to find out how grep actually processes the things coming in. I'm seeing all this pattern here, grep underscore and then a function name. It tells me that there might be some macroing going on where they have like the name of the command and then in it. No, it's not how it matches. I want to find how it processes standard in and when it like decides to process that to standard out. Git directory, but this is what? Grep in it. This doesn't make sense. Why is Git part of this? Like, I don't understand. Okay, I mean, this seems like a different. Yeah, line by line. The thing is like, okay. This should work because echo is producing a line. Like, we should get lines into here. Like, if we remove cat, we replace this with cat, it works. And we get lines. We replace with grep. Now it's like, no, I'm not gonna output anything. Like, we are inputting the lines. Yeah. But of course, in bash it does work. Yeah, of course that is different. But what if we then do new line? No. Yeah, so that's what I was trying to figure out. Like, what do we need to do for grep to actually output something? Okay, I think I'm gonna just make, like, this could be a special case for grep, or I mean, it might also be for other things as well. Like cat works. Cat just outputs whatever comes in. It even doesn't. It doesn't even wait for this line here. Maybe there's something with like. Maybe it's looking for like, you know, maybe it's like raw mode or something. Can you enable raw mode in Bash? How to enable... But it shouldn't be a difference, because it should still have received the things from standard in. But maybe, okay, what I was thinking is that maybe grep looks at the terminal attributes, and it's like, so you're using your own bash, but the original grep, and you can't get the two to integrate correctly. Yeah, because grep is just an executable, and we are printing into the grep standard in. But I'm gonna try something here. I'm gonna go to, like, if we cat this, you can see if we run this with Runic, you can see it, like, it says hello and then sleeping now. Will it be the same with bash? Is the question now. Oh. Yes, it is. Okay. Because I was thinking maybe when it's not raw mode, it would, but maybe it's because it's like it's a complete. I was like, maybe it's waiting for a new line, but then it's like, well, this is a complete statement, so it should output it anyway. I don't know. It just, yeah. But what I was gonna try is I'm gonna try go to main. And then we have like enable raw mode somewhere. And let's not do this. And if we do this now, of course this still works. Good. If we change to grep, okay. Yeah, I was like, this should work. No, it's not. It doesn't work. Okay. So that wasn't it. It's just grep also. It's like grep is the only thing I have trouble with for specific processes. Like that's the first process that's or like executable that I have had trouble actually writing to here. Because cat works and it outputs fine. So I'm not sure what's going on here. Like I'm trying to figure out if there's something we're not doing or what could be the issue. But I think maybe we should, I mean, we've got the basic thing working. So I think that this would be a bug that would be solved later. Of course it needs to be solved because this should be like one of those common patterns. Of course, you're trying to use grep. You're trying to use anything that has some sort of streaming pattern. I forgot actually if this did work or not. I think this did not work. No. So if you have some kind of streaming here, it doesn't work with, but it does work with bash, but not with. So if you have something that's blocking here, and then grep is like trying to read from it. Like I'm not sure what is the standard procedure. Do we have to close standard in and then reopen it, or what is happening? Like we are writing to the thing. Do we need to do something else? Like we are flashing as well. So it's like, what else do we need to do? For grep to actually do something. Because there might be some kind of standard procedure that I'm missing, that we're not doing. That's working for cat, but not for grep. Or it's like right now it's working for cat, but it's not working for grep. So there might be some kind of thing we're missing with the pipes stuff. Yeah. Because it's like if we try this, let's do grep.zig, and we'll do a main. So we'll do this manually here. Grep hello. We need an allocator, so let's just use page allocator. Okay, so that's grep. And we'll say standard in behavior is pipe. Actually, you know what? I already have a thing for this. So let's say this is grep hello. And we'll go back. Oh shit, did I remove the commands and stuff? Wait, I thought I had like a test here. Yeah, this one maybe. No? Yes, it is. Okay, this one. Yeah, so let's do this one. Grep hello. Okay. So if we try this, what was it called? Poll standard in. Okay, so now grep has spawned up. If we press enter, we can see what the state of the pipes are for this. Okay, I'm gonna read your message here first. Doesn't help us not, but I found this Unix Linux stack exchange. Grep fields as hello and will normally print matching lines immediately if standard out with a terminal, but in pipeline, grep standing out to another pipe to the terminal or next stage of cat. When standing out is in the terminal, grep uses fully buffered output, so it does not so it accumulates data in a buffer and doesn't flush it immediately. If standing out as a terminal is line buffer, oh. Yeah, that might explain it, but it's like, okay, well, how do you actually tell it to output data then? Or maybe fool it to be in a terminal or something. So do we need like a virtual do we need like a terminal thing for this to work properly? Like we need to set some kind of flag on the process or something. Okay, so I put in writing to started in hello. Okay, and we can see that it still doesn't have anything for us in standard out. So grep, it doesn't show anything. And then we read, let's read, in how can we do? In, and then that still doesn't have anything for us to read. Yeah. Yeah. Okay. So it's like I'm gonna say like process terminal like how does it determine process terminal flags and command line options flags when spawning a process like grep, how to tell it it's in a terminal. Now where did AI go? Grep line buffered. Yeah, the thing is though, I would like to fix this so we could so we don't have to do that. Is that a thing like grep? Oops. Because it would be annoying if you would have to write that. Okay, so that works. Thank you. Okay, now we just need to figure out how to actually make that happen. term is not terminal. This is like the term signal. Okay. Yeah. It's really nice to get it confirmed. We just need to figure out how to make it think it's in a terminal. Because I don't want to have to kind of create a special case for grep and add this. I mean, I guess we could. But also it should depend on the environment of where Runic is spawned from as well. But how would you ever get the data out? Like if it's only like a small amount of data, do you have to kind of close? I guess maybe you would close grep first then. But it still wouldn't work in a streaming manner. So that's kind of strange. But maybe it's more for if you want to kind of process huge amounts of data at once. Maybe, I don't know. Environment. But this is just environment variables. And it should be inherited anyway. Yeah, I guess the question is like, how does it determine to do that? We could look at the source code, I guess, to look at that line buffered. So we can see this is line buffered. It's true if the option is on, but then it's like there's nothing else telling it to be line buffered. But maybe there's another setting though. Flush. So when is it flushing? Okay. I'm not even sure if I'm looking at the correct source code though. That's the thing as well. Well, here is main. What the hell? Why did I not see it before? Grepston must be a PTY slave. Okay. I mean, technically, we could like make a built-in, but it just feels like it should just be setting some flag somewhere to make it work. We could also like hard code in. Okay, if you're trying to use grep, let's make sure we add line buffer to it or something. But then it's like, okay, well, what if other processes also has that issue? Like, we should make everything think that it's like, if we're in a terminal, the process we spawn should also think it's like a terminal or something. PTY slave. Okay, I need to... Is that some kind of pipe thing? Pseudo terminal. Oh, okay. Can be read. You could also all wrap stand above. Oh well, grab. Okay. Okay, actually, I want to try that. So basically, wait, this isn't even the correct place. What's happening? This isn't even used. IR, wait, evaluator, exec. Oh, it's happening here, okay. Okay. So is that it? Oops. Dun, dun. Wait. Oh. Sorry, yeah. Let's add 2. There we go. Yo, Piano, thank you. Welcome back. Hey, thank you. Thank you for the help. That's very good to know. Like you see, it's like maybe it's foolish of me to try and do this when I don't really know that much about. And I mean, I'm learning, but you know, about Linux and terminals and stuff. But yeah, we are learning. Oh yeah, sorry. Oh god damn it, this was still here. There we go. Now it works. Everything is line buffered. And this of course still works. Very, very cool. Yes. Awesome. Okay, let's call that a fix. I mean, it's like a duct tape fix, but it's you know, it's working. Where were we? Evaluator. So, I mean, basically, we could just go into standard buff, look at what this is doing. Yeah, it's less of a duct tape than calling line buffer every time. Yes, because that only works for grep, so that is true. But what I want to do is basically, I want to go in here and look what is this thing doing, and then basically just copy that in here. So that we don't have to like spin up another process every time we do something. Yeah. But yeah, that could be a future thing. Okay. Cool. Thank you very much for the help, by the way. Awesome. So this is solved, but it's like duct tape. But it does work. So we can you know, put that off for later. I'm gonna add this in like maybe. Now it is a to do in the code, so we don't need to write it down here. Awesome. Okay, so that is done. Now, what is the next step? So we have a couple of major things that we need to do. Mainly, it's like where. Yeah, functions are a big thing. But now we have blocks. So we have kind of the basic foundation for being able to call functions. And of course, there's going to be different kinds of functions in the sense of either a function is like. So I'm thinking of doing something akin to what Haskell is doing with the monads. Just because the thing is, if we're thinking about what is happening with the types. So out in the outermost context of a runic function or of a runic file, it's kind of like being inside the executing function already, which I've talked about a bunch of times. But this is a runic file is kind of like a function and a module as well. But so every statement here is like executed, right? Now, if you don't actually execute anything, we could infer the type of this file to be a function that doesn't take anything into standard in. And then I'm gonna say at for the function name here, and doesn't take any parameters, and it doesn't output anything either. So that is now the type of this function. It's basically, it doesn't do anything basically, but it could potentially have side effects though. You know, if you call, well, actually no, because let's say an executable. So for example, cat, the type of cat is actually a function kind of that takes a string input. Now I'm not sure if it's going to be like a streaming. It's like implied that it's streaming. So, but let's say we wrap it in string just to make this clear here. So the standard in is a stream of strings, and then of course we have the name cat, and then you have parameters, which, you know, for all executables we don't really know what parameters they have, but what we do know is we can define it as a variadic number of arguments where the type is like, we have like args, and this is an array of strings. So that is the arguments. It's an array of strings with unknown length. Could be 0, could be 1, could be 2, could be many. And then the standard out is the stream string again. So this is like the type. All right, see you later, piano. This is the type of every executable. Oh yeah, and let's not forget about the error as well. So this could be an error also. Yeah, we're streaming. Now the thing about the functions in Runic is that the result type here is not actually what you get in the end. It's what's being outputted over time, like in a streaming fashion. So actually, like the like cat can stream things and then return an error. So you can get like both of these. But yeah, so, or we can say that maybe a stream has a built-in error type, maybe. So I don't know. You could get some like standard in error maybe here. Maybe this is like built into the stream, and this would be like standard out error or something. I don't know. Or exec error. Something like this. Okay, but the point is that we are type inferring as well. So this is the inferred type of this function of this file right now, because we don't have any. Okay, let's make it more clear here. Let's not talk about the file as a function, because that might be confusing. Let's talk about just a normal function here. So I'm gonna say we have a function called hello. Okay, I'm not defining the types because they are kind of inferred. They could be inferred, so we could potentially do this so that you don't have to type out the types themselves, so they are inferred by the statements inside. So let's say you have a function hello. Now I'm gonna say here that this is the type of this is function void hello void. So function void standard in, void standard out, and hello. So if you call this function, it won't, you know, it won't do anything, of course, and you don't have to pass any arguments to it. But let's now call echo in here. Okay, now this changes the type of the function, because we call echo. Now all of a sudden we have a stream here. We have a stream. So we actually, this changes the whole like type of the function, like the result type. And this is what I mean about this being kind of like a monad in Haskell. It's like we have like the body of a function is, or a block in this case, is like a list of statements. which in monad language is kind of like, yeah, it's a bunch of expressions that are executed one after the other, and they can but the types have to be the same of the expressions. So this type is when it's called, is going to be this result here, which is kind of then like the IO monad in Haskell. So this is kind of the same thing here, where you call this, it outputs, we get this here. So and also it does change the input as well, although echo actually it doesn't do anything with standard in at this point, but it does change the input as well to be this standard. So basically, as soon as you call an executable in a function, the whole function type changes. The standard in type changes, and this changes to match whatever is called inside. But if we make a function, let's call it pure, because you'll see why. Now this is void, pure void. Okay, and then we're like, okay, well, let's take a parameter x, which is an int, and then I'm not sure exactly how the syntax is going to be for this, but let's just return x plus 5, let's say. Now what is happening here is like this takes, of course it takes like an integer here, but the output is going to be an integer, but it's just one integer, it's not a stream. But it could be converted into a stream that just has one item in it, and then it exits basically. But yeah, it doesn't take anything standard in, it produces that. However, what if we now, and also this is a pure function, so it doesn't have any side effects or anything. So we're operating kind of outside of the stream kind of monad, whatever. So this doesn't actually have any side effects. That is for like IO stuff, basically. But it could potentially, you could have like, you could have a value outside here, which is 3, and then you kind of modify it here. So now it's not pure anymore, but whatever. But let's see. What if we have another function, which is like add 5. Okay. So we return x plus 5, but now we change the input to be a stream of ints. And then the output is now also going to be a stream of ints, because we take... No, actually, wait. Let's do it like this. So this is now void add 5. So it's the same thing there. Int, right. Now, but what we do now is we say, hey, I want standard in plus 5. And we remove this parameter. So standard in plus 5, and then we don't actually need to return, I don't think. No. So we say standard in plus 5. Oh, yeah, there's no semicolon either. Is going to standard out or something like this. I'm not sure exactly how this is gonna work, but we'll see. This could also be the bash way of writing or something like this, but let's do this to make it more clear, maybe. So now this doesn't, now the type changes. This doesn't take any parameters. The input is actually now a stream of ints, because it's like inferred because of this expression here. And then it also puts things out to standard out, so this would stream out in like ints out, but it doesn't have an error now. I guess standard in could still, maybe we could have an error, I'm not sure exactly, but this now takes standard in as a stream of ints and then outputs a stream of out. So it's gonna connect standard in, and it's gonna run this until standard in is disconnected, and then it's gonna continue. And then you could have this again, which I'm not sure exactly how this would work, but maybe I'm not sure if you're gonna be able to reconnect standard in. Yes, I mean I guess you would, because every time we call this, it actually connects standard in, but then echo disconnects immediately. And then if you call this again, we connect standard in again here, but then echo closes it again. So but if you call cat, standard in is connected and then it doesn't disconnect. So we are reusing like the outer like standard in here. So it's kind of like implicitly saying this here, standard in on everything, and also like standard out and all that standard, but yeah. Does that work? I assume it's going to try add find to a standard input and seem like undefined behavior. No, but okay. So how it's gonna work is basically you're gonna have like a parse int function, for example, and this is gonna take a stream of strings and output a stream of ints, or like a parse int error. So you would so this would be the guard here, because if you try to connect something that is not a stream of ints into add 5 as a standard in, then it's going to be a type error. So we have to kind of pass through a parsing function first. So we parse the int. Now I'm not sure how this is going to look in here, but let's say we have this function. Now you can say echo 5 parse int and then add 5, and you would get an int out, which is like adding this to the thing. And the plus would be like if you use standard in like this, like the plus is like it's like a built-in operator. So it's not like we can define an overload of plus or anything. It's more like we're gonna check, okay, can you add, this is an int and this is a number, so can you add those together and get a result? Yes, you can. Okay, this is a stream of ints, or it's gonna, we know that standard in is a stream, but we don't know what the input is. So we can say that, okay, well, if you're trying to add 5 to it, we can infer that it's going to be a stream of ints, and so you can kind of build it up like this. So so this will now be +5, and then it's outputted to standard out. But I don't think we actually need to have this. This will kind of be inferred. So yeah, it's kind of like calling a process. Well, not really, but we're taking the we're connecting standard in, and then kind of this becomes like a function almost that we're executing. Every time we get standard in integer here, we add 5 to it, and that's the output. So it's like that goes out to standard out. So it's a typed pipe, right? This echo will echo a standard, or it will echo a string. It will produce a string stream, which is just a 5 in this case, but like one item with 5 in it. But it goes into parse int, which takes a string and returns like a stream of ints. And now this output stream is an integer. So we pipe it into add, which takes a stream of ints and also outputs ints. and that would then be, you know, at the end here, it would be, you know, we would, okay, this would be piped to standard out basically, and in the process of doing that, we're gonna coerce the integer to a string, because we need to kind of, it's to display it properly. So this would, you know, behind the scenes, this would go into standard out and then also be converted into a string at the same time. But it's a way to kind of work with pipes in a type safe manner. Now, this is just an experiment. It's just a theory, an idea. So it's like, I'm not even sure if this is going to be useful, but I just thought, hey, that would be kind of cool to have like typed pipes, and we'll see how useful that is. I'm not sure if it's ever going to be useful, but it's an experiment. So yeah, I just wanted to talk a little bit about functions, because that is kind of the next step in this here. So I think what we're gonna do is the first step, I just want to have functions that does not have any types or anything for standard in, standard out. And they're just going to be normal functions like this, and you're going to be able to execute statements inside, just like a block basically. It's like having a block of code, because this would be essentially this, but you can repeat it however many times you want. So if you type hello, this is going to be equivalent basically to doing this, basically. And then once that is done, I want to add parameters so that we can be able to pass parameters into functions. And then much later, maybe we'll get to this. Because that's going to be all like type checker stuff, but it's also going to be like these things, like when you actually try to use standard in for something in like some kind of expression like this. That's going to be interesting. So are all functions with side effects implicitly piping to standard in? You could say all functions that use standard in here are gonna connect to standard in from outside. And then also, whenever you have a function or a block like this that calls echo, echo is actually connected to standard in. And that's how it works in bash 2, if I'm not mistaken there. Where if you call icat inside of a subshell or something, it still connects to standard in and still blocks there until you cancel it. So like when you just call cat, this is now connected to standard in, and you type some stuff, it's gonna execute it. If you type some stuff and then flush it, it's like flushing it out. And if you close standard in, cat actually exits here. No, it's not specific to echo. It's for all executables. So it's like when we encounter an identifier like this echo here that we have not defined in the language, we are executing it as an executable. But when we type hello here, of course, it's going to be a function instead, because we have it in scope here. But technically, hello would also get standard in connected to it, and then it would kind of inherit, like, or forward it here. But yeah, let's start with these basic functions. So, well, we should start at instructions, actually. What do we need for this? So basically, we have jump with conditional if we want. we have, of course, we have fork as well. So whenever you call a function, we should probably like fork it and then wait for it, because that will or do we actually? Maybe we don't need to do that actually. Maybe we just need to jump to the specific instruction set. So we jump to the function, and the function then returns. But that is also like we need like a return instruction to be able to go back to where we were. It's like stream propagation. Kind of strange, but I think you get it. Yeah, but the thing about the thing about, oops, where were we? What could we say here? Like, let's say we do only cat into grep hello, let's say. Okay, and then we run bash on this now, because that should be fully doable. You can see that it's connected now to standard in. And if I type something here and flush it, of course nothing's going through because grep did not get a hello. But if we do this, we don't get anything. But if we type enter, it does go out. So echo does echo, or I mean hello does work, but everything else doesn't work. So this is now connected to standard in, but yeah, and of course in bash when you just call this, it will be the keyboard. And if we do Control D, we close standard in, which also closes cat standard in, which then closes cat standard out once it has outputted everything. And then standard in of grep is closed, and then that also closes. So if we run this in Runic, we get the same thing. Or not. What the fuck? Okay, why is that not? Okay, that's another bug then. It should work, but okay, I'll write that down as well. Oops. Cat into grep hello does not react on standard in. But yeah, the point is that if you have a, let's say you have a function in, I mean, let's say you have like cat sh, and you have a function here, and we call cat. It would just be like calling cat. What, returned it to cat? What do you mean? Cat receives standard in. Cat receives standard in. Cat is the first thing. It's like they're implicitly saying this. Standard in goes into. Okay, I'm not sure, but basically, cat gets connected to standard in. It's not grep that has standard in. It's cat. And then whenever cat outputs goes into grep. And then grep outputs to standard out. And once cat standard in has closed, like the standard in comes into cat here, it's basically piped into cat. And once this is closed, cat will close once it has outputted everything to grep. And then cat is closed, and then grep says that, oh, standard in is closed. Okay, well then output, process everything, and exit. I mean, at least that's how it works in Runic. I'm not sure exactly how it's wired up in Bash, but it's not like this is not outputting back to cat. I'm not sure if I misunderstood what you wrote there. Like cat decides when grep should close here, basically, because standard in here is like grep is open as long as standard in is open here. That's how I see it. But then what I was trying to say here is that cat here inherits standard in. So if I just call hello here, it should work exactly like cat. So if we do bash cat, oh, sorry, we don't type function there. There we go. See, this is exactly the same as cat. So it's like the things that happen inside a function is like everything that you connect here or that you call here will be connected to the actual, like the standard in, and the standard out will go out. Piping was right to left. I mean, I see it as left to right, but I don't know. It depends on, like, I see it as cat happens first and then grep happens. Not the other way around. Okay, what do we need for functions? So we need to be able to jump. Like, how I'm gonna say a function. Let's go back to function. I'm gonna clear all this. So let's just make a simple function here. The types doesn't really matter right now. It could be anything here. I just have to have types for the parser to work. But we're not actually doing any type checking for this right now. And so we echo hello. So this is the basic case that I want to make work here. Now what kind of instructions would this yield here? Well, this function is going to get compiled into some kind of function declaration. So it would be its own like instruction island somewhere where the only thing that happens is that we call echo hello. Okay, or actually we compile this block of code here. That's what's happening. Okay, and then we have these instructions. That is basically the two things that should be in the main. Well, actually, this is not in main. Actually, this is the only thing that's in the main instruction set. And then this function is somewhere else, where the instruction set consists of whatever expression is here, which is this block here. So what we would expect here is that we would expect, let's have main set here, and we basically call hello. So what is that? So let's have, this is a function called hello. So first I want to push the address of the where we should like return to. So we're gonna push yeah, whatever you know, relative relative plus 1. That's where we want to return to. Or actually, well, it's going to be somewhere down here. But there's some kind of label. So it's going to be like after call or return address. Okay, so we're pushing the return address label. And then we just jump unconditionally basically to the function. So this would be like, I don't know, yeah, it's some kind of address here. So it's like jump to hello. Okay. And then afterwards, it's like we get back here. This is return address. This is the label return address here. And then it's like we're done. So we just exit. Okay, so that's the main thing. And then hello. This is hello. Would just be first we just, you know, we compile this expression and call it. Or yeah, we just compile this expression actually. Wait, no. Yeah. No, yeah, no, yeah. Actually, what do we do here? We compile it. And I think we get the result and wait for it, I think. So it's like whatever function body is here, it's stored in a, we're gonna store that in a ref. And they're gonna set function body to be equal to, you know, the compiled function. So the no, wait. How does this gonna work? No, I think we just compile this expression. So this is gonna be the compiled function body here. And then at the end, yeah, because in order to support like async functions, we just return here. So we pop the thing, and I'm not actually sure how to read that, but we pop it and then we jump back to return address, but we need to kind of, okay, so let's just say that we get some kind of ref here. I don't remember exactly, but I think if we create a ref here, we can store that in the ref and then jump back. Which will jump back here and then exit. Yeah, and then we don't really wait for this, although we would wait for it here because this is a statement here. This is a statement. And then we would wait for that. So wait for whatever we get back. Actually, how do we wait for it? Because we don't know, we don't have like a fork or anything. Maybe we do always need to create a fork for a function call actually. Okay, so instead of no, wait, because we're implicitly, yeah, we do need to create a fork. Although if it's called synchronously, maybe we can avoid using a fork, and then we actually don't need to wait for this. Yeah. But then if you want to call it asynchronously like this, what we do is instead, so let's let's say that that is done. But if we do this, what we do is instead of jumping, we don't even need to push here. We just need to fork into hello with inherit, and then we just wait for that. So we ref fork stored in this ref. We wait for that thread to exit. No, we don't, because it's an async. No, we just fork it. Yeah. But then over here is like we don't actually jump back. Interesting. Maybe they could, I mean, there could be some kind of check here that checks like, okay, did we execute, like a runtime check, did we execute in an asynchronous manner? But then that would require something. I mean, we could, yeah, I mean, I guess we could push an invisible argument. We could push like sync here, like sync is true, and over here we would pop, or actually, yeah, we would do like ref sync pop into sync, and we would check like jump if sync is true to something, like to the next one, or if it's false, we would jump to over here, which is like the exit function. But if sync is true, we actually jump back. We could do that, or we could also, we could like always fork, and then this part would, like, if it's async, we do this. If it's sync, we would create a ref, store it here, and then wait for it here. That seems like a easier thing to do, perhaps. Yeah, let's do that. Let's not do all this weird stuff up here. So that would be that, and this would be so now this is the same for both examples, but here we create a ref to store fork the thread handle there, and then we wait for that thread handle. So that's the synchronous version. This is the asynchronous version where we don't wait. Okay. Yeah, so we don't actually need new instructions. We just need to create this thing here. So let's go to the compiler, and we'll go to like compile statement. So we have binding, return, expression. We also have, I think, believe, function declaration, maybe, or maybe not actually. No. that is actually an expression. Function declaration. Yeah. Right. So that will be in here. All right. Compile function declaration. Okay. All right. So we need an instruction set for where the body is going to be. So this is going to be the instruction set. And instruction set. And we're gonna have the original instruction set. So in this instruction set, we're going to say, we're going to do compile actually it's like expression, yeah. Compile expression source, and no, the expression is the body. Okay, so that would now compile the function body in its own like instruction set. And that's all we need. Like, we only need the function body, and once it's done, it's done. I mean, what we could add an implicit exit 0 at the end, but I don't think we really need to. We could like automatically, we're like automatically doing that anyway. So now we have that. What we do then is in the main instruction set, we create a ref. Actually, this depends if it's like async or not. So we could actually implement async directly here, although I don't even have this stored here. No, because this is the function declaration. Wait, we're not calling the function, right? Yeah. So what is this gonna be? This is gonna be like an instruction address. Or maybe it's just this part? No, because this gives us like a result, and in this case we would just get like this block here. Man, I don't remember now. This and the block is here. This returns like the ref, which is what? The ref of the block that we fork. Oh yeah. But here we don't actually have anything we return. It's just an instruction island. So I guess we don't care about this. We just do But actually we do care about this. If this part in here is happening asynchronously, we need to wait for that as well. So we do need two versions of the function actually. Or we need some kind of logic in here that would handle the async case. Okay, you know what? I'm not gonna build that right now. I'm just gonna do wait, like automatically wait here. So this would be the result of the function body, and then we would do if is waitable. Wait. Results. Then we also do wait. Results dot value dot wait. This is function body. Yeah. Okay. So this is the sync version only then. So I guess if it wasn't a sync, no, the declaration doesn't know about sync. But basically, we would have to kind of keep track of, is this in a sync thing? Then we need to kind of wait for this, because there's no way of knowing what's happening inside of the function body. Yeah, that's interesting. So yeah, that's gonna be figure out how to make this async. Because the problem is that the expression that's inside is always async, basically. But how do we then... I mean, I guess what we could do is we could keep a scope. We could store this result in a function, in like a scope, where if you call this function, we would be able to grab out this result and wait for that. Yeah. Okay. Right, and then in the end, the function declaration is basically nothing right now, I don't think. No, it's an instruction address, actually. I think. Yeah, that also needs to be... We also need to know about that. So actually, we need to declare here. We need to declare... name I guess. Wait. If we have a name, we declare it, I guess. Otherwise, it's like an anonymous function. The result is the instruction address. So this is basically function location is gonna be result from location. Instruction address is gonna be absolute, and it's going to be instruction set 0. So that's the function location. And that's what's going to be stored here, I guess. mutable false. Okay, so that's declared. And then the result of this is also going to be the function location. Yeah, I think what's going to happen here is this declare is going to be, we're going to have a result here which is different. Maybe it's going to be, or maybe you have a value that's like a pointer to a function, or yeah, a function reference value that is going to be including both the function but also the ref that it holds. Now the thing about the ref though, that's not gonna work if you call the function multiple times. Okay, yeah, that's not gonna work. Yeah. Because this result here is like, if you compile a block, it's like we're spawning a thread, and then we're storing the thread handle in a ref. The problem with the refs though is they are kind of like global variables. So if you call it another time, like in an async, it's gonna overwrite whatever was in the previous ref. So now we lose the thread handle that we had. So I'm not sure how we're gonna fix that, but we need some kind of dynamic array thing for that. Figure out how to be able to call async functions multiple times and have the results not be overwritten in a ref. Okay. Oh, you need the identifier. Wait, what? No, you don't need the identifier. You need the name. There we go. Okay, but anyway, now it should work for synchronous only. But asynchronous, yeah, we do need to work out some more, because it's like you're spawning multiple threads, but it's basically the problem is, where do we keep track of where those thread handles are, and how do we wait for all of them at the end? And if we do something like this, like we want to store the process somewhere, well, I guess it would be stored in this ref here though, so I guess that's fine. But anyway, or the actually the variable there. Okay, we'll see what happens. But now we should have the function declaration actually working. Function call is not working for now though, but I think we should be able to like compile this and get at least get up to the hello. I'm gonna do this to see what happens. What is this? Let's do that, and we'll go to function, and I want to do this. Okay, unsupported address type. Oh, so so when we compile this, unsupported address type. Oops. Where is this happening? to address, right? Which is called from where? Whole bunch of places. I think it's like when we're trying to write it out. Right, it's trying to, okay, it's trying to make it into an address number. From location. Ah, I see. Yeah, because the thing is, like, the address, we don't have a place for the instructions. I guess, yeah, because it's like the instructions, like in a real process, the instructions share like address space with memory, but I've actually made them separate here. But I also have an address that is like just a number, so we should be able to kind of, so the, but yeah, so it's like once we made it into a number, how do we get it back? And for that I'm using like a map address function. Why do we have two of those? Oh, I see. Which just but this is only for memory addresses, not for instruction addresses. So this is basically saying, hey, if you're in the read-only part, you're gonna be a read-only location. If you're in the stack part, you're a stack address. Otherwise, we're kind of saying that you should be a ref. But location should probably be like part of this as well. Or I mean instruction address. Or if we could figure out how to avoid that, maybe. I mean, what we could do is say, yeah, we could add, actually, yeah, instead of having a location or an address, instead of having an address, we would have a function reference. And then the function reference would be over here. So you would be instruction set. So, or not a set, but a instruction, so basically function address, which is going to be an instruction address. Okay. And the other thing that we wanted to have was the reference to the inner ref, but now let's forget about that. So it's just going to be an instruction address. Okay. And here we have like deserialize. We're gonna say, I'm just gonna say this for now. We don't really use this right now anyway. It's in the future we might want to have something like this to be able to output the IR into a separate file that you can then like look at, and then compile it also later, so you could like write like the byte code or whatever. It's not bytecode, but it's like the IR as a language, basically. And then format would simply format the type there. So let's add this here, function ref. We could add a format function. And we'll just do writer print format function address. That should have a format function. I hope, yes. Yeah. Compile call, of course. Oh yeah, actually call a function. Yeah. So now we have a function call. Actually, yeah. Wait. Call eval if it's a slice. What is actually? It's actually going to be. Wait, a slice? Calling. Compile expression. Oh yeah, because this will go into the identifier, right? Yeah. It's going to the identifier, and then we're trying to look it up. Otherwise, it's a slice. Yeah. Okay. So we look it up. So actually, this is going to end up being a function ref. And then we're going to be able to compile a function call. There we go. That we don't have, but we can add it. For now, I'm gonna do that and return that. Okay, and now we have materialize string. Function ref. There we go. Okay. Where were we? Compile function declaration, I think. So actually now, when we declare this, we don't store the location like this. What we do is we create an instruction address. Yeah, there we go. And we declare, we set this to be now a from value function reference. And I think that's what we called it. No? Function address. Okay. And then this will be from value. Actually, okay. Let's create this as a value instead then. From value. Oh, this is a value. Actually. Then IR value. And then function ref. Function address. There we are. And then over here it's going to be from value function address. Or here we can just say from actually. And here as well. Wait, why are you an error? You shouldn't be an error. Or? Oh, you can be an error, okay. Fine. Okay. There we go. So now we declare this. So now later we can look in this scope. If we have this name and we try to call it, we know where to get the function address from. So, and also if this is called as an expression, like if you declare a function inside, you know, if you say like const function equals function blah blah blah, then that will also be stored, like the reference will be stored there as well. And actually this is ref now, not address. There we go. Okay, so if we try to compile this now, we should see something. Okay, close the output window. Here we have echo hello, of course. In the read-only data instructions is that we can see here we have set 0, which really does nothing here. This is like the usual setup of the main process, and then of course you have exit at the end. So these are always here. So that means we have nothing. Nothing is happening in this program, basically. It's gonna forward standard I/O to our internal pipes. It's gonna fork those streaming of those pipes, and then it's gonna exit. So nothing is happening. But then we have set 4, which is the function declaration. So this is well, actually this is this should be this part. This is the block. So this first we have a ref that's called block standard out pipe. Yeah, this is the block expression in here. But if we would, let's say we remove this, let's say we actually only say, hey, this is just a 0. So a function expression does not need to be a block. It can be just a literal if you want as well. So now if we look at this, we get the normal things, but then we don't get anything over here. This is an empty set, which is interesting because that should work, because we're trying to jump to this function. It's like the thread is like, well, now you don't have any instructions left, so we're done. Yeah, and then you can see here in the actual thing happening here, it's like going through everything and then just exiting. So it seems to work. And now we're gonna try to call this, and of course this is not gonna, well, it might compile expression. No, unsupported expression. Yeah. So this should be a function call at this point that calls hello, and then in the compiler, compile function call. So now we need to figure this out here. So if we open up IR functions and we look at, so this is the function call part, or this rather here. And executable, of course, is a value. Now we should already have the function reference in there. So we can kind of assume that the value is going to be a function ref. Actually, we could just grab the ref out here if we want, maybe. No, let's keep it like this. But the function ref is going to be executable. Well, it's not executable, is it? It's a function. Function ref value is a function ref. So that's our function ref, and then we have function address. It's going to be this. Okay, so now we know where we should fork to. And let's call like function call ref. It's going to be this ref over here. So this is the function call. Make a new ref, and the name is function call. And then we will fork with inherit. Source result is going to be stored in function ref call. The destination is the function address, and that's it for the fork. And then we also wait for, no, actually we don't wait here. We just return the ref because the statement compiler is waiting for it later. But yeah, that's it, I think. Now you might be wondering what we do with the arguments. Well, I think what we will do with the arguments is we're gonna push them to the stack, and then the function will pop them later and kind of declare them as in the scope as things. So that's what's gonna happen there. But we don't really need to do that for this to work. So let's try and make this work first. I'm gonna do that for now. And then what's your issue here? Oh yeah, from location. Here we go. Okay. Now let's see what this will do. And there you go. It works. Did you eat something? No, I haven't eaten. I did skip breakfast today as well, so I should probably call it quits here pretty soon and eat something. But yeah, we've got the basic functions working now, so so there you go. That was pretty simple actually. But the hard part is like figuring out exactly what to do. But if we look at the instructions now, right now I've implemented functions declarations and functions calls. Well, it's not morning anymore. It's 2 o'clock almost here in the afternoon. So we're doing this. So this is the ref here that we're doing there. This is the fork. This is the wait. And then this is the exit. And then we go down to the thing, which is this is like, well, actually, let's look at where we're forking. We're forking to instruction set 4, which is this part here, which just executes the block directly. And oh, we're actually waiting for this here. Yeah, because it's happening inside of actually, yeah, because it's happening in the fork. Oh man, why didn't I think about that? It's just happening in the fork. But yeah, if let's say the thing about this here is that this ref is actually not like a local ref, it's a global ref. So if you would call this asynchronously multiple times, this ref would be like, we're waiting for this ref here. But the thing is, if you call this a second time, this will get overwritten by the new thread. So then the old thread is like, oh, but now we're waiting for the other thread, actually. Actually, that won't happen because Well, it might happen. There could be a sync issue, but this, when at the time where this is waiting, it actually sets the thread context to wait for another thread ID or a closable. So actually, I think we could get away with this actually, unless you call it, unless you have, or there's kind of like a race condition could happen here. I'm so close to completing the project. I don't know about that. But I am close to getting back to where we were before, with streaming actually working with blocks. So I'm actually further ahead than the previous kind of version that we had. But then I need to implement, like when functions work, it's just a matter of making like all other expressions work, like the arithmetic, logic, comparison. I think we even did like for loops. I'm not sure actually, but basically those are kind of trivial. Like the hard part is this, like the functions and the async stuff and the blocks and the streaming of the pipes. That is like the hard part. So that's what I'm trying to figure out first, and then the rest could we can just do easily. But well, I say that now, but that's how it feels like now anyway. Okay, and then this forks 5, which is the actual block content, which forks again because we have the executable call. So here's the executable call in here. Right, so that makes sense. Well, I'm not gonna think too much about what's happening here, but you can see that there's a lot of streaming happening here, and then we end. But we're basically just waiting for a hello to echo. I don't know why there's so much streaming going on here. It likes to loop through a whole bunch of times before anything happens. But yeah, it does work. Okay. Cool. Well, we don't really have support for async right now, so I'm not gonna like try to do that. But yeah, we can call hello any number of times or not. Duplicate ref. What? What do you mean? Oh, duplicate ref. Okay, so we can't do that any number of times. That is interesting. So, okay, so we actually do need... Okay, I need to rethink about the refs. Yeah. Wait, duplicate ref? How can we get duplicate refs? Okay, I think I know what the issue is. So basically, until now, the refs have been... The address of the refs have been known at compile time, but maybe they should be known at runtime actually. And then that means that we actually need to allocate, like that means that we actually need to kind of look into where could they be stored. I mean, I guess it's like now we're in the territory of garbage collection now, or memory management. The refs right now is kind of like every ref gets an address appointed to it in compile time, but actually it should be done in runtime. I'm just gonna see if I can fix this real quick, because it's probably not that hard to fix. If we go to the compiler, it has like a context. Where are we? Where is it? Here. So we have this ref counter somewhere. I mean, we have refs, and then we have this current ref. So this is where I mean, well, it's happening compile time. But I don't think we should have it done in compile time. It should be done in runtime. But then how would you identify the ref? That's the next issue, maybe. I mean, it could be an identifier. We could also make it thread local as well. But then it's no. But the identifier is going to be an issue anyway, because we're going to run into the same issue there. No, because it could be an identifier, but then no, it's, I think it's okay, I need to think about that. I can't solve it right now, but yeah, we got the basic functions working, so that is really great. We can't call it multiple times because of the IR thing there, so I'll add that to the to-do, or I mean the we'll add this to a bug, I guess. So cannot call function multiple times. Oops, no. Possible solution, make refs thread local. Other way of how to identify refs. Oh. So it's like, yeah, a bunch of questions really, but we need to figure that out. Okay, awesome. Yeah, this still doesn't work with IR. But yeah, this works anyway. I mean, you can do this to make it work. There you go. Okay, yeah. And then what about pipes? Does it work with pipes? Who knows? Let's grep. Hello. Let's try this now. Something, hello, something. So that should, hey! It works. So this is already more advanced than my earlier version of the language. Now, because we can pipe function calls and block statements without issues. Super cool. Arguments does not work yet. But yeah, that's awesome. Okay. So can't call function multiple times. That's a bug. What we need to do as well, I need to add, so compiler does have function declarations, and we also have function calls, but we need to be able to process arguments somehow. Arguments, and make refs work again. And I'll just add that there. All right, so that is that. What else are we doing? It would be good to also get, like, once functions are done, it would be good to get to binding like variables and stuff. That is also a huge thing. So to fix. So basically bindings, yeah, making bindings work and being able to like reference those. But yeah. Awesome. Okay, but yeah, I'm gonna eat something now. So you have a nice day, everyone, and thank you very much for watching and joining me here. And I'll see you